The term space weather refers to the variable conditions on the sun and in space that can influence life on Earth, as well as impact technology. The sun is the main source of space weather. Sudden bursts of plasma and magnetic field structures from the sun's atmosphere called coronal mass ejections, together with sudden bursts of radiation or solar flares, all cause space weather effects here on Earth. Space weather can produce electromagnetic fields that induce extreme currents in wires, disrupting power lines and even causing widespread blackouts. Severe space weather also produces solar energetic particles, which can damage satellites used for commercial communications, global positioning, intelligence gathering, and weather forecasting. The strongest geomagnetic storm on record is the Carrington event of August through September of 1859. Named after the British astronomer Richard Carrington. During this event, currents electrified telegraph lines, shocking technicians and setting their telegraph papers on fire. And northern lights, electrically charged particles from the sun that entered the Earth's atmosphere, were visible as far south as Cuba and Hawaii. Another significant space weather event took place March 13, 1989. A powerful geomagnetic storm set off a major power blackout in Canada that left 6 million people without electricity for 9 hours. According to the North American Electric Reliability Corporation, the flare disrupted electric power transmission from the Hydro-Quebec generating station and even melted some power transformers in New Jersey. Much like hurricane classifications, the National Oceanic and Atmospheric Administration space weather scales correlate space weather events with their likely effects on technological systems. The scales describe the environmental disturbances for 3 event types: geomagnetic storms, which is the G scale, solar radiation storms, the S scale, and radio blackouts, the R scale. The scales have numbered levels, analogous to hurricanes, tornadoes, and earthquakes that convey severity. The vast majority of level 5 events will not cause catastrophic damage to the electric grid. On average, the Earth is impacted by such storms about 4 times during an 11-year solar cycle. So many large storms have impacted the planet since the Carrington storm with much less significant impact. All weather on Earth, from the surface of the planet out into space, it all begins with the sun. Space weather and terrestrial weather, the weather that we feel here at the surface, are all influenced by small changes that the sun undergoes during its solar cycle. The most important impact the sun has on Earth is from the brightness or irradiance of the sun itself. The sun's very stable, though, and only changes by 1% or less over solar cycles. It should be noted that the change in climate due to solar variability is likely small, but more research needs to be done. It's believed that short-lived solar explosions don't influence weather events like heat waves, but longer-term variations in solar output might affect Earth's climate. The latter half of the 17th century experienced a decades-long stretch of minimal solar activity known as the Maunder Minimum, which many scientists suspect may have triggered the Little Ice Age. It was a cold spell that chilled the northern hemisphere from about 1650 to 1850. These are interesting things with JC.